So here we are converting the same code that I showed you in the previous slide. You can see it here in red. And that was basically going from 0 to 6. And then every time you are setting this value to your index of your array. So we are trying to convert the same code to MIPS. And this is what we have here. So first we are basically reserving that size that you need. So we have 6 elements, and you are basically, you could name it anything. So we are going with str. So this str doesn't mean it's not a type. It's not that it's a string or anything like that. This is just a name that we chose. It's not a reserved word in MIPS. Then you have your size. So we are working with characters, and each character is a byte. So we are going with a byte. And then we want to initialize them to 0. And then we have 6 of them. So this is what's happening here. Basically, we are just blocking off some space in the memory so we can read or write from it. The next thing that is happening is you are initializing I to 0. So that is for the for loop. And we have seen how to do for loops before. So basically, we are doing a I to 0 here. And then you are in your T0, you are saving the value 10 or A in hex. So that we are gonna use because later we're gonna assign this value here to our elements in the array. So we are saving that in T0 from now. And then the other thing that you do, we are getting the base address. So we saw the LA that is basically loading the address. So this base, it's a register, but here, just to be clear, we are using base. But in MIPS, if you are actually coding this, you have to put, for example, S0 or S1. So you have to use one of the registers. So here, for simplicity, we have this name. And then after that, how the LA worked, we said there's a register, and then the second argument is actually your label. So what this does, it's gonna take the address of this str. So you don't need to know where it actually this one is initialized. That's what the LA does do for you. So it's gonna take the address of the str and save that into the register base. So now you have basically for your 0 element. So basically str 0. You have that address. And then we have our loop. So you see that here we are taking our well, first we are calculating that index that we are at. So if we are temp, let's say this is going to be our final address for that ith element, and we are adding I to the base. So if base is the, let's say it is 10010000, if I is 0, you're going to get the same address. If I is 1, you're going to get the next byte. If I is 2, you're going to get the third byte, and so on. So every time, so base is not changing here. Base is always this one, and we are doing it one time. It's not on a loop. But I is changing. So here you see that we have add I1. So every time we are incrementing I. So basically, we're going to get from the base, its first element, and then adding 1 to it, and then adding 2 to it, 3 to it, so on. And every time we are saving that in temp. So that's so far here. And then the next thing that we are doing a store byte. So if you recall, a store byte takes some value from your register to your memory. So this is the value that we have that we want to save. This is T1, that's the number 10, or hex A. So that is what we are saving, so T1. And where are we saving it? We are saving it in the memory location that is pointed to by temp, and that temp being our ith element that is calculated here dynamically. So here you have basically this thing. You have your stri is equal to the hex number A or 10. And then we talked about this, we are adding I, incrementing I. And last thing is that basically we are checking if I is less than 6, we are going back to the loop. So that's basically this condition here. So that's what's happening here. And we are going to walk through and trace this code line by line.